Hi, my name is Dimitro, and today I'll show you how we validate analytics code before it reaches production by embedding a three-layer testing framework directly into CI/CD. You'll see how this reduces rework, tightens governance, and shortens feedback loops. So, analytics engineering has exploded in scope. More models, more contributors, more surface area for defects. Originally, data engineers own the whole stack: ingestion, transformation, modeling, and even BI before it was called BI. So the bottom arrow here shows a single lane, one team end-to-end, which worked perfectly when the scope of stakeholder count was smaller. It centralized knowledge, but created a throughput bottleneck. As demand grew, right, with split responsibilities, BI engineers took over the semantic and presentation layers. Metrics, dashboards, storytelling remains with them, while data engineers focused on data pipelines and core models. Currently, you can even hear about Tableau Ops as a whole separate pillar of data operations. So the bottom arrow is has two lanes. Specialization increased quality, but handoffs and dependencies slowed iteration and introduced seams where defects obviously can cripple in and fall in. Spark and stored procedures kind of started organizing the code where we at least know in the end where the product that we're supposed to deliver is actually being delivered. Nevertheless, we have very little visibility into the previous steps in the pipeline. So we're moving into the era of dbt, right? Traditional ETL, the extract, transform, load process for data before loading, is being switched to the modern ELT process, where extract happens first, then load, then transform. So the raw data lands first, and then we do the transformation in the warehouse. With this shift, right, raw SQL models are now transformed in the warehouse via tools like dbt. So anyone who knows SQL, analysts, BI, even domain teams, they can shape transformations. So the bottom area here widens to multiple contributor lanes. The data engineer role pretty much is concerned with the data source ingestion, which is getting more complex as there are more different ways of ingesting the data. For instance, event streaming, right? Then SQL coders are folks who are going to do the actual transformation in the data warehouse, and then analytics will be handled by BI engineering. So that puts us to the motivation and problem of the current study, right? ETL and self-serve analytics multiplied SQL variability, but SQL lacks robust universal refactoring and link tools. We know how many different flavors of SQL there are. You cannot just carry over MySQL code and run it in Trino, or Snowflake code and run it in Redshift and things like that. So we need a lightweight, enforceable approach to validate code early in our pipeline. And the goal that we set before ourselves is to build a validation into the CI/CD directly, so defects are caught at a commit time, not in production when the model has already failed and created an issue. So we are relying on CI/CD workflow, continuous integration, continuous delivery. So a disciplined pipeline is needed to collaborate, standardize, and scale analytics with transparency. In this ELT paradigm, right, CI/CD pipelines are central for automating analytics. We're integrating changes incrementally with slow little changes to each file or one file at a time, and deploy governed data assets. So the analytics code base, right, is treated as a Git version controlled project. Every commit triggers that pipeline run. If the pipeline is not passing, then some changes needs to happen in between for folks to address. Once all of the changes pass, we can actually deploy these instantly in production. So you don't have to wait till the next release of software. You don't have to wait to entire redeployment of the production on a daily refresh. You just go into the production once you merge the changes and those changes are validated. How do we ensure this continuous integration, right? We would have a set of checks. We call them here data checkpoints. So these are the ones that should promote DataOps principles: modularity, collaboration, extensibility, right? So pipeline has these sequential stages, as we see: lint, optimize, parse, validate, observe, and deploy. And each stage runs parallel jobs of automated checks. So in total, there are 23 scripts here that implement all controls, enforcing governance per given commit. Obviously, this is just a demonstration. You can add as many additional checks as you want, or reduce the number of them based on the use case. So for automation and standardization, right, we run on the lint stage SQL linting and naming convention checks. On efficiency and optimization, we apply AI-based feedback. We double check if there is any duplicated code in the repo using vector similarity. Whenever it comes to parsing, we analyze the abstract syntax tree to ensure that there is no dead code, that the column is properly used, and the long queries are not making their way into the DBT modeling, as DB keys suggesting us to break down the code as much as possible into sizable chunks that can be tested, validated, and assembled separately. The validation enforces the branch freshness so that you wouldn't accidentally overwrite somebody else's changes because you did not rebase your Git branch. Schedule freezes are accounting for weekends or holidays where the breaks would be detrimental, since there is not as much support on the DevOps or data engineering side. There usually would be in case of a failure. And then obviously observability that ensures unit and UAT testing, the runtime thresholds, and things like that. So go into the next part, the implementation details. So GitLab CI.yaml file polices the entire pipeline itself. It orders all of these Python-based checks into a specific set of requirements. Then the GitLab runner clones commit every single time we are pushing a new change, and the clean Docker container is created per given job. All of the dependencies, the latest version of the repository, and all of the changes are making into that Docker container that is being kicked off. Then MR updates trigger the fresh pipeline. And then obviously if the failure happens, then the entire pipeline is being hindered by that specific job. If it succeeds and the entire pipeline passes, then we're releasing all of the changes into production. In this tool stack, we chose Iceberg as it is a vendor agnostic open source table format to deliver our models. And then we're relying on native DBT supporting catalog as our documentation. It is a static catalog, yet it aggregates all of the information that exists in our repo, everything that we demanded that the analyst actually put and document whenever it comes to this modeling. So how did we test all of this? There are 3 different layers of testing, right? So we want to ensure that different layers of testing are appropriate for this job. Pipeline is absolutely everything that you see, and we consider it to be a black box where it is a scenario test bed. So we're submitting a compliant and faulty MR, and then we see how that behaves. The stage 1 is the integration of all of the jobs together to ensure that controls run cohesively, that one control would prevent the other control from running, and the failed controls would not let the pipeline fail. And then the white box, that's the unit most granular testing for each control script for just correctness. And I'm going to talk a little bit more in detail here, right? So for the white box, we verify each control script behaves deterministically. We literally go by line of code and we validate each line with a test case to ensure that it behaves as expected. So we're using the PyTest here, and then the coverage.py produces a report for us where we can check the number of files, functions, and classes that have been tested. For the 23 control modules, right, we ran the total of 368 unit tests, which is 1-to-4 test ratio. And majority of these are covered and behave as expected. In the next part, for the gray box, here there is the control cohesiveness across the CI jobs itself. So besides those lint, optimize, parse, validate, observe stages, we added another 2 stages. So one of the stages is the QA gate that executes all 23 controls together and then builds different artifacts, and then the summary that aggregates and produces the JUnit for MR badge. So all of these confirm the integrity. They have the numeric summary. They confirm that every single part of the pipeline executed as expected cohesively in the run environment, because the PyTesting, the white box testing, that can be done locally, right? You can execute it directly from your directory, not even having access to absolutely all of the underlying infrastructure. Here, we're actually running it in production environment, and we're ensuring that in production grade environment, it behaves as expected as well. And finally, we're moving to the pipeline level testing. So we're viewing the entire pipeline as a service. So we only interact through Git merge request, which is why this is a black box testing. So we have 2 different scenarios. We started with the scenario A, which is not compliant, and we have different failing iterations here, right? So we're submitting the unapproved tag at first, and then that will pretty much prevent us from succeeding on the very first stage. It will just fail. Then we would fix it, and we will go back and we would submit an MR that has distinct used with the aggregation in SQL, and our AI feedback should check that as well, and it will fail, which will prevent us from moving to the next stage. So then we're going to the part where our model is too long. Same thing is gonna now fail at the 3rd stage. We're going back and we're going to the stale branch. We did not rebase in a while, so a lot of folks who we're working with have already submitted their changes before our changes made it in. So check branch freshness will fail as well. And then finally, we go to the point where the missing configure test, because in this repository, we require every analyst to submit at least one test case for the model that they submitted to confirm that it behaves as expected, and that fails as well. Finally, we are producing a compliance scenario, so all prior issues are fixed and MR is unblocked. So all of these will actually pass. In this case, we're going into the deployment. The model is released into the production, and then you can see, right, that the catalog has been populated with the test model that we created in this case, which has its name, description, and then all of the columns. And then if we are to go into the actual query engine, we would be able to pull this model up from the production database. So as a result, we are here, right, noticing that the defective submissions, they're blocked automatically, that correct changes flow without manual QA bottlenecks, there is shorter feedback cycle. So instead of us relying on somebody else to review the pipeline. Everything is done automatically. We don't have to wait. We instantly get the gratification. Obviously, the checks take a couple minutes to spin up because they're like 20-second runtime to spin up the container, build a container, and then actually execute the specific check. And the more complex the check is, the more time it takes. For instance, to build a manifest for the entire repository may take a minute, given the fact that it would have around 3,000 models. And then finally, we have the auditable trail, because we can go in and actually figure out if there like every single pipeline that executed within GitLab itself. And then as far as limitations, obviously there is no quantitative baseline across legacy and a new workflow. So we would recommend rolling this out in stages, as in you would create a repository and you would create one check, and that check would be run. So if the model runs, it can be submitted. Then the next check you would roll out is the model length. Then you would add another check, and you would build up this whole stack, that you have a framework already for appending to and expanding the breadth and the width of depth of your entire pipeline. This way you can add, remove, you can configure different rules. For instance, if you're creating a snapshot, right, you would have different set of checks compared to a model creation. Or if you're just updating documentation, right, and you're submitting it to the repository, half of these checks would be irrelevant, so you would not want to use them. But in ideal world scenario, right, you would be in a situation where you would have a repo, you would create a repo, you would manage the repository that does not have any of these controls. You would measure all of its performance, failures, number of contributions and whatnot, and then you would benchmark it against changes that happen whenever you're submitting a new MR with all of the automated changes and validation checks embedded into the pipeline itself. Obviously, this is the single organization implemented, so how does it generalize is still a question, and how to make it generalized, because obviously every single organization have a different scenario. Even the layout of the DBT project itself can change. Some folks are just using staging and landing area. Some are using the bronze, silver, gold architecture, the medallion one. Some folks rely on staging marts, an intermediate layer for the transformations. Some of them expand there. For instance, at my organization, we also have the reporting layer, and we have the primary layer that pulls the common components a little bit more far upstream, and have a separate analytics warehousing team manage that to ensure the correctness. But yes, the anecdotal user feedback is another limitation, as I did not perform any survey here on the feedback. And then obviously the human factor adoption. The more checks you have, the more problematic it is for somebody to submit an MR, the more negative sentiment they would have whenever it comes to adoptions of this. So as far as conclusions, end-to-end validation of analytics, CI/CD pipeline is feasible and cost-effective. Why is it cost-effective? Because it removes any manual effort from the data engineering support headcount, which is something that you may have had on call on a daily basis, validating and supporting their pipeline. Instead of doing that, their work is pretty much concentrated on DevOps and software engineering to ensure that these checks in place, and coming up with new checks and filtering those. So you are effectively managing your time. Whenever you have around 60 analysts, that economies of scale really start working in your favor, because updating one check is way easier than working through 60 different MRs. 3-layer testing improves quality and governance, because only good quality tested models make it into your pipeline. And then finally, you can see a scalable blueprint where extensions or shortenings of the pipeline and the number of checks can be addressed. So you can add alerting, monitoring, and whatnot to be deployed with every single run of the pipeline to make sure that you're staying current and you would see the results of the pipeline itself. And that's it. Thank you, folks.